Hi everyone, welcome to section 7.3. This lesson will be broken into 3 parts. The first part is going to focus on multiplying radical expressions. The question that you see before you, so the cube root of 4 times the cube root of 5, this is intended to be an exploration problem. So what I would like you to do is pause the video and try to work through it. See if you can work through some either intuitions or assumptions and see what you come up with. Once you're done, unpause the video and go ahead and begin to take notes and check your work. So I'm going to go a little bit of a longer way because I want to connect this concept that we have in 7.3 to 7.2. So the first thing that I want to note here is that I can rewrite this so that instead of looking at cubed roots, I can write this in an exponential form. So I'm noticing that my index is 3 in both cases, so I can write these problems to become 4 raised to the 1/3 power times 5 raised to the 1/3 power. And if you recall, or if you reference your 7.2 guided notes, one of our rules had kind of indicated that if you have a situation where your powers match, I can shorthand this. So I could rewrite this as 4 times 5 raised to the 1/3. From here, I can clean this up further because I know what 4 times 5 is. 4 times 5 will be 20, and then I will have that power to the 1/3. If I wanted to rewrite this back in its radical form, I would reference the value that I have in the denominator of my exponent, and then I would move that over so that it now becomes a cubed root with the 20 underneath it. We could shorthand this though, so let me clean up our original problem. Let me get rid of those circles and arrows. Okay, so same idea. If the radicands are using the same kind of radical, or same index, or yeah, same radical, so same cube root, I can do one big cube root and put the 4 and the 5 underneath it. My multiplication sign looks like it fell down, so let me rewrite that so that it's clearer. This will then give me a cube root of 20. Let's move on to the next problem where we are working with variables. So the next problem, we are working with the square root of x plus 5 times the square root of x minus 5. And again, if we don't see the index, that means that they are squares. So working with that same idea as before, what we can note here is that we have one big square root, and then underneath it, we can have our number of x plus 5 times our number of x minus 5. The parentheses that I'm using are very important in here, because without them, we may not realize that we will have to, as you probably guessed based off of what you're looking at on the screen, that we're going to have to FOIL. Again, the other reason is because we want to know x plus 5 is representing that one number underneath the first radical, and x minus 5 is representing that second number underneath the second radical in the problem. So we're going to go ahead and FOIL. So to begin, remember that FOIL stands for first. So x times x, and actually let me go ahead and draw my magical square root there. So we'll get x squared followed by our outer, so that will be x times negative 5. That's going to give us negative 5x times our inner, so that's going to be 5 times x, so positive 5x. And lastly, our last terms, so 5 times negative 5, which gives us negative 25. And what we want to note here is that we can clean things up a little bit more. Notice that we have a negative 5x and a positive 5x. These are like terms. Both of them just have a variable x next to them. And their coefficients, negative 5 and 5, are inverses of one another, so that makes this cancel itself out. So now we have a square root with x squared. Oop, let me be consistent with my coloring. X squared minus 25. Please note that this is as far as you can go with your answer. So this is your final solution. What I want to note, I'm going to actually go ahead and highlight this in pink really quick. We cannot say that the square root of x squared minus 25 is the same thing as the square root of x squared minus the square root of 25. We cannot break things into individual terms. Or, I'm sorry, we cannot give each individual term its own root. This is essentially messing with the number. What I want you to note is that the x squared minus 25 represents one big number. We can only break apart values if it's just multiplication and or division. Once you start putting in subtraction or addition, it becomes problematic. So again, what I have circled in yellow, whether with or without the grouping symbols, is my final solution. The next two problems are going to be practice problems, so what I would encourage you to do is please pause the video, give them a try first, and then come back. Alright, so let's start these problems out. Hopefully you've had a chance to practice them. Notice that I have the same index, so I can write this as one big sixth root, and underneath it I have 7m and 10m. If you are doing this by hand and you notice my radical's a little short, always go ahead and feel free to carry it out, and if you want to, you can kind of break that little end to indicate that that's where it ends, just so that your reader knows that everything that they're looking at is underneath the radical. So now there really isn't much else left to do other than take care of the multiplication. So 7 times 10 will give me 70, and m times m will give me m squared. And again, here is my final solution. The next problem, notice that they both have an index of 9 for the root. So I can write this as one big root, ninth root, excuse me, and then underneath it we will have our x plus 2 divided by 5 times our 11 over x minus 3. So when you're looking at this, you can kind of put the ninth root on the back burner just as long as you don't forget to write it in subsequent steps. But what I want you to note is, take a look at the multiplication that you have here. You have a multiplication of fractions. What I would encourage you to do is go through and double check to see if there's anything that you can cross cancel. Really quickly, just as a refresher, that x plus 2 represents one number, x minus 3 represents one number. So please note that you cannot cancel out terms. So I can't go through and say, for example, cross cancel the x's out, because x plus 2 is a different number than x minus 3. Okay, the only way that I can get rid of that x plus 2 in the top is if I have an x plus 2 in the bottom. Hopefully that explanation is clear. So my next step, I'm going to have my ninth root, and all I can do is I can write out the multiplication. So the top one would be 11 times x plus 2, and that's all going to be over 5 times the quantity of x minus 3. You can stop your result here, or if you want to take it further, you can actually do the multiplication. So that would give me 11x plus 22 all over 5x minus 15. Either of these solutions would be acceptable. So the last part that we want to note here, everyone, is can we make a general rule? And so what I want to note here is, again, for example, say I give you something like the nth root of a, and I'm going to ask you to multiply that with the nth root of b. So the rule that I'm setting up, I want it to clearly indicate to you that I'm using the same index on my root. So my final result should be, as a general rule, I can say that the nth root of a times the nth root of b should give me the nth root of a times b. I hope that this video was helpful. If you have any other questions, please let me know.